spend a little time to get more familiar with our controller. You can see we have the LCD display and the shortcut keys below. You can see some of the shortcut keys have multiple icons. Let's use 9 as a reference. With the main screen displayed, when we press this button, the shortcut key activated will be Z+. The second icon we see in the bottom left corner is the secondary shortcut key, or the Shift and shortcut key. In this case, if I press Shift and Z+, it will activate the mobile tool touch-off sequence. Finally, if we are in a screen where we need to input a numerical value, it will act as the number 9. Now, let's focus back on the display itself. When looking at the display, we will first take note of the area here showing our coordinates. There are 2 sets of coordinates, mechanical home and workpiece home. The workpiece home origin is displayed with a number beside the X, Y, and Z. In this case, we can see we have 1X, 1Y, and 1Z. What this is showing us is the current distance from the last workpiece start position. As we move the machine around the table, the numbers will get smaller as it gets closer to said position, and the numbers will get larger as we move further away. Technically, it's the opposite for the Z values, as they are in a negative number, but we won't think too hard about that right now. We can toggle the display from the workpiece home position to the mechanical home position by pressing Shift +8. The mechanical home position is the physical 0, 0, 0 position of the machine. It references the distance from the 3 limit sensors and cannot be reset like the workpiece origin position can. This display is only used when troubleshooting or setting physical coordinates like the fixed tool touch-off device location, which we'll get into a little bit later. Below the coordinate display, we can see which mode of movement we are in, jogging or stepping. Jogging means that when I press any one of the axis movement shortcut keys, it will move in that direction until I let go. Pressing Shift on its own will toggle from jogging to stepping. A stepping movement will move the machine a predetermined amount. We will talk about the types of movement in more detail shortly. In the top right corner, we can see that the machine is currently sitting idle. When the machine is moving, it will say run. Or if a program is paused, it will say pause. Below that, we see S off. If we press the spindle power button, it will show which spindle gear we are currently in. The spindle gear RPM is set by a parameter on the VFD. We will talk about your spindle RPMs as we move through the controller. Below that, we can see our jog speed. It will either be set to high or slow. We can toggle this option by pressing 5. If the machine is currently in stepping mode, 5 will not toggle the jog speed. It must be in the jog setting. Below that, we have our feed rate percentage. The feed rate display can be seen from 0% to 120%. If we program the machine to cut at 100 inches per minute and the feed rate override is set to 100%, the machine will cut at 100 inches per minute. If the feed rate override were to be set to 50%, then the feed rate of the machine would be reduced to 50 inches per minute. If the feed rate override is set to 0%, you will get an alarm when trying to move the machine around the table or when you try to run a program. It cannot be left at 0%. To clear the alarm, press Escape. We will now toggle the display from our main screen to our movement screen by pressing the OK button. In this display, we can see our high jog speed, our slow jog speed, our step amounts for X and Y, and our step amounts for Z. Below that, we can see which file we currently have loaded on the machine. If there's no file loaded, it will say no file. Pressing Escape or the left arrow button will take us out of this screen. Finally, if we press the menu button, we can access the controller menu. We'll get into that a little bit later. Now that we understand what the three display screens are and how to access them, we can move down to our buttons. Starting with the buttons on the left-hand side, we can see the green Start button, the orange Pause button, and the red Stop button. As I'm sure you can guess, pressing the green Start button will start the program, the orange Pause button will pause the program, and the red Stop button will stop the program. The red Stop button will also stop the machine from doing any application it is currently doing and is not limited to only stopping the loaded program. If you press the Pause button while the machine is in operation, the machine will stop and raise the spindle. Pressing the green Start button will pick up from where the program left off. If you press the red Stop button during a program, you can press the Shift plus green Start button to pick up the program from where it stopped. If the machine loses power or loses reference, you will not be able to pick up from where it last left off. There is also a large emergency stop button located on the handheld controller. You would typically only press this button in an emergency, as it will not only stop the machine, but throw it out of reference. Once this button has been pressed, you will need to send the machine back to the mechanical home position by pressing Shift and 7 before you can continue machine operation. You will not be able to press the Shift plus green Start button to pick up from where you last left off. The K1 and K2 buttons may not be utilized on your machine. For example, if you had a machine with an automatic tool changer, pressing the K2 button would raise and lower the pneumatic dust collection boot. These buttons are not utilized on the Professor M, Professor V, Basic V, or Basic VP CNC machines, unless you have ordered the machine with customized options. The spindle power button will turn the spindle on, and pressing the spindle power button again will turn the spindle off. Moving to the right, we can see our OK button and cursors. Pressing the OK button will take us to our secondary screen, showing our high and slow jog speed and the step amounts, as well as which file we currently have loaded. Pressing the menu button will take us to our drop-down menu. Pressing either the OK or right button will take us further into the drop-down menu. Pressing left or escape will take us backwards through the drop-down menu. With the main screen displayed, the up, down, left, right, and escape buttons will do nothing. Moving down to the right-hand side of the controller, we can see the XY equals 0 button. Pressing the XY equals 0 button will activate a prompt asking if you want to set a new XY start position. Pressing OK will set the workpiece start position to the current machine location. Pressing the Z equals 0 button will do the same thing, but only for the Z value. If you wanted to change just your X coordinate, you would press Shift and XY equals 0. If you want to change just the Y coordinate, you would press Shift plus Z equals 0. As previously mentioned, pressing the Shift button on its own will toggle the machine from jogging to stepping and back to jogging. Pressing Shift and many of the other buttons will activate the secondary shortcut function. Pressing squiggly line plus and squiggly line minus buttons will increase or decrease the feed rate override percentage. With the spindle on, pressing Shift and squiggly line plus will increase the spindle RPM. Pressing Shift and squiggly line minus will decrease the RPM. With these buttons here, you can increase and decrease both the RPM and feed rate while the machine is in operation. This will be useful when working with new materials or trying out new router bits. Typically, we want to let the software determine the feed rate or RPM for day-to-day operations. Pressing the 00 button will activate a subprogram that moves the machine to the workpiece origin position 30 millimeters above Z0. Please note, it is not advised to press this button after changing material or router bits. Hypothetically, if the material was significantly thicker or the router bit was significantly longer, it could drive the bit into the table or material. Pressing Shift and the 00 button will move the machine to the park position. If you would like to set a park position, you will need to press the menu button and scroll down to Operations. Then scroll down to Park MCS Site. Then select Park Mode and down to Park Site to activate the Park Position option. Once Park Site has been selected, then scroll down to Park Site. Input Site allows us to input the mechanical position for where we would like the machine to park. On this machine, I will set the park position to 1x, 2000y, and -1 for z. The other way to set the park position would be to jog the machine to the desired park location and select number 2, Select Site. Moving over to our yellow buttons, we will first look at the main shortcut keys. IV plus and IV minus do nothing, as these would be utilized on a 4-axis CNC. This machine is 3-axis only, so these buttons are dead, like K1 and K2. Pressing the X, Y, or Z, positive or negative buttons will move the machine in that direction, whether it be in stepping or jogging. Pressing number 5 with the wavy line will toggle the machine between high and slow jog speeds when in the jog setting. Pressing Shift and 7 will activate the homing sequence to find the limit sensors. Pressing Shift and 8 will toggle the display between our workpiece home position and our mechanical home position. Pressing Shift and 9 will activate the shortcut key for our mobile tool touch-off device. On the machines that utilize the pneumatic reference pins, pressing Shift and 6 will raise and lower said pins. On the machines that utilize a fixed position tool sensor, pressing Shift and 3 will activate this sequence. Keeping all of this information in mind, we really only have 5 steps we need to complete before we can successfully run a program. Step 1 is to send the machine back to the mechanical home position or the reference position. Step 2 is to secure the material to the table. Step 3 is to set the X, Y, and Z origin position. Step 4 is to load the program. And step 5 is to turn on our dust collection. Once these steps are completed, we are ready to press the green Start button and run our program. We are now ready to set our workpiece origin position. First, let's make sure the display is set to the workpiece origin. For this project, we are using the bottom left corner for our XY datum position and our material surface as the Z datum position. To get the machine to our start position, we will first use the high jog setting, getting us relatively close to our desired location. We will then switch from the high jog speed to the slow jog speed, allowing us to creep just a little bit closer. Once we are about ½ an inch away from the desired location, I will change my stepping amounts to 0.5 millimeter. I will then switch my movement method from jogging to stepping. With our stepping amount set, I will now align the center of the router bit on the corner of our workpiece. With the machine in the correct location, I will now press the XY equals 0 button to set my new XY start position. Now to set our Z workpiece start position. We must first raise the router bit high enough off the table that we can fit the mobile tool touch-off device underneath it. With the device in place, we press Shift and 9 to activate the tool touch-off sequence. The spindle will slowly come down until the router bit presses down on the mobile tool touch-off device. Once this sequence has been completed, the Z value will show 69.5 millimeters. The machine knows the thickness of the tool touch-off device, so if we bring our bit down to the table, the readout should be plus or minus 0.2 millimeter when using mechanical clamps. It should be 0 when using vacuum suction. Now that our X, Y, and Z workpiece start positions have been set, we are ready to load our program. Okay. Scroll down to the program you want to load, press OK to select, you'll see the check mark. Pressing 1 will load the program, 2 will delete the program, and 3 will copy it to memory. We want to load the program, so we're going to press 1. We can verify that we have the correct program loaded by pressing the OK button. The file currently loaded will be shown at the bottom of the display. A quick recap of the 5 steps we need to complete before we can run a program. Step 1. The homing sequence has been completed and the machine knows where it is. Step 2. Our material is secured to the work table. Step 3. The X, Y, and Z workpiece origins have been set. Step 4. The program has been loaded. All that's left is to turn on our dust collection system and we're ready to press the green button. The LED underglow warns us that the machine is about to start running.